The purpose of today's video is to review the method for finding the circumference of any circle and the method for finding the arc length of any circle. But before we start finding the circumference and the arc length, we're going to review a few things from the past. First of all, every circle, no matter what size it is, has a diameter, a measurement across the circle. Every circle, no matter what size it is, also has a circumference. That's the measurement all the way around the outside of the circle. And whether you have a small circle, a medium-sized circle, one that's a little bigger than that, one a little smaller than that, one a lot smaller than that, one bigger, all of those circles have a diameter and all of those circles have a circumference. And if you notice, when the diameter is shorter, the circumference is also shorter. So as the diameter shrinks in size, the circumference also shrinks in size. So one amazing thing about circles is that it's about 3 times as far to go around the outside of the circle as it is to go across the circle. And that's true whether you're going around the outside of a large circle with a large diameter or whether you're going around the outside of a small circle with a small diameter. And I'm sure that you know that if you take the circumference of any circle and divide it by its diameter, you will always get the same answer. It is the irrational number pi, 3.14159265, and it just continues on and on without ever having a repeating pattern. So once again, every circle, whether it's a large circle or a smaller circle, when you take its circumference and divide it by its diameter, the answer will always come out to the same number, the number 3.14159, which continues forever, which in our study of math, that number has a special name. It's named with the Greek letter pi. The directions in our textbook are written right on the top left-hand side of the screen right now, attending to precision. You have sometimes used 3.14 to approximate the value of pi. Throughout this chapter, you should use the pi key on your calculator, then round to the hundredths place unless instructed otherwise. So how do you use the pi key on your Casio FX300ES Plus? Well, the pi key is found by first pressing the shift button, and then you hit the button with an X and a 10 to the X power, and you'll see right above that button, there's a little gold pi symbol. So when you hit the shift button and you hit that second button, you will have a pi symbol on your screen. If you hit the equal sign and then the SD button, it will change the pi symbol into a rounded off version of pi, 3.141592654. That will be on your screen. So when you're using your Casio FX300ES Plus, shift and then that bottom middle key will put the pi symbol on your screen. Anytime the directions ask for the exact answer, you must leave your answer in terms of pi. Your exact answers will look like 14 pi centimeters or 3 pi over 2 miles. Anytime the directions do not ask for the exact answer, you must leave your answer in terms of pi until you finish your calculations. Do not round off. Leave the pi symbol on the screen. When you finish all of your calculations, hit the SD button and take the decimal on your screen and round it off to the nearest hundredth. If they do not ask for the exact answer, then your answers will look like 43.98 centimeters or 4.71 miles. Now to remind you of what the circumference formula is. There are 2 versions of the circumference formula. The first version is when you are given the diameter of the circle in the problem. The second version of the circumference formula is usually used when you are given the radius of the circle in the problem. So the first version of the circumference formula is circumference equals pi times the diameter. And the second version of the circumference formula is circumference equals 2 times pi times the radius. And as you know, 2 times the radius in the second formula would give you the exact same distance as the diameter in the first formula. The arc length formula is arc length equals arc measure over 360 multiplied by the circumference. So depending on whether you know the diameter or the radius, you could be using the formula arc length equals arc measure over 360 times pi times diameter, or you could be using the formula arc length equals arc measure over 360 equals 2 times pi times the radius. What's the difference between arc measure and arc length? Well, arc length is in linear units. It's actually length. How far is it around part of the circle? That's measured in feet, inches, miles, centimeters, or any other linear units. Arc measure, on the other hand, is measured in degrees. So arc measure would be measured with a protractor. Arc length could be measured with a ruler, although it would have to be flexible so that you could wrap it around the circle. Here's a story to help you determine the difference between arc measure and arc length. Two brothers live near lakes but in different states. The guy in California challenges his brother in Minnesota to a race. They will each run halfway around the lake near their own house while timing themselves. The best time wins. The brother from Minnesota, who will follow the green path around the lake near his house, is worried that it might not be fair. But agrees when the California brother, who will follow the red path, assures him that they will both run 180 degrees. Does the brother from California have an unfair advantage? He obviously does have an unfair advantage because he lives near a smaller lake. So both brothers will run 180 degrees, halfway around the circle. But obviously the brother from Minnesota lives near a larger lake, so the length of his run will be a lot further than the length of the brother from California. So two circles can have the same arc measure, but not the same arc length. Arc measure is based on degrees. It will be from 0 to 360. Arc length is, remember, in linear units, it's how many miles, inches, feet, or centimeters measure around the circle. Now we're going to do some examples. In this problem, we're asked to find the circumference. So for circumference, there are two formulas that we could possibly use. We can use the formula that says circumference equals pi times diameter, or we could use the formula that says circumference equals 2 times pi times radius. In this problem, we are given the diameter. So we will use this formula to solve our problem. So we know the circumference is pi times the diameter, which in this problem is 14 inches. So the circumference is going to be 14 pi, and that's what you want to have on your calculator screen right now. Then you hit the SD button, and it tells you that the circumference is 43.98229715. And we should round off to the nearest hundredth, like we said earlier. So we're going to take a look at those numbers right there. And the final answer for this problem is that the circumference, which is how far it is all the way around the circle, is 43.98. inches. In our next example, they're asking us for the exact circumference. And so if we're trying to find the circumference, there's two formulas. Circumference equals pi times diameter, or we could use circumference equals 2 times pi times radius. On this problem, the 10 miles is the radius, so we'll be using that formula. So circumference is 2 times pi times 10. So our circumference is 20 pi, and that's what it should say on your calculator screen. And on this problem, they want the exact circumference. So they don't want us to change it to a decimal and round it off. They want the exact answer. So on this problem, the circumference, or the distance all the way around the outside of the circle, is 20 pi miles. In this problem, they're asking us for the arc length. The arc length formula is arc length equals arc measure over 360 times the circumference. And since they're giving us the radius in this problem, I'm going to use 2 pi r for the circumference. So now when I go to solve this problem, the arc measure is a right angle, so this arc is 90 degrees. The arc measure is 90 over 360 times 2 times pi times the radius, which is 8. So when you type this into your calculator, it's probably easiest just to use the fraction button and put in 90 over 360, and then times 2 times pi times 8. And when you type that in, it's going to come out to 4 pi. And that's what should be on your calculator screen. It should look just like that, no rounding off. Now that we've done all the calculations, we're going to hit the SD button, and you're going to see 12.56637.061 on the screen, and we should round off to the nearest hundredth. So that second 6 is going to cause the first 6 to become a 7. So on this problem, the arc length, or the actual distance, if you had to run from here to here, would be 12.57 centimeters. On this problem, they want the exact arc length. So for this problem, we're going to find the arc length by taking the arc measure over 360 times the circumference. And again, they gave us the radius, so I'm going to use 2 pi r. So we're going to have an arc measure of 120 degrees over 360 degrees times 2 times pi times 2. And again, type that into your calculator. It's probably easiest to use the fraction button for the first part, and then just times 2 times pi times 2. And when you work that out, what you should see on your calculator screen is 4 over 3 pi. And so on this problem, they're asking us for the exact answer. So we do not want to go in and change that to a decimal and round it off. So what we just found out is if we had to travel from here to here along the edge of the circle, that distance would be 4 over 3 pi feet. All right, on this problem, they want us to find the circumference again. So we have circumference equals pi times diameter, or circumference equals 2 times pi times radius. They gave us the diameter, so we're going to use this formula here. So circumference equals pi times 20. So the circumference is 20 pi. Again, that's what should be on your calculator screen. And then when you hit the SD button, you'll see that you get 62.83185307. And we're required to round off to the nearest hundredth. So we just found out that the circumference, or the distance all the way around the outside of the circle, is 62.83 inches. This problem, they want the exact circumference. So we know we're going to use circumference equals pi times diameter, or circumference equals 2 times pi times radius. On this problem, they gave us the radius, so we'll use that formula. So our circumference will be 2 times pi times 13. So our circumference will be 26 pi. And they're just asking us for the exact answer, no rounding off. So we do not want to press the SD button and round off on our calculator. So what we just found out was, if you travel all the way around the outside of this circle, you'll be traveling 26 pi miles. Here we want the arc length again. So the arc length equals the arc measure over 360 times the circumference, and they gave us the radius, so I'm using 2 pi r for my circumference formula. So the arc length is going to be 60 over 360 times 2 times pi times 11. And when you type that into your Casio FX 300 ES Plus, what you should see when you're done is 11 over 3 pi, and they are not asking us for the exact answer, so we do want to find the decimal. So now we hit the SD button, and you should see 11.51917306, and we need to know about that much of the answer. So the 9 is going to bump the 1 up so that it's a 2 in our rounded off answer. So what we just found out is, if we had to travel from here to here along the outside of the circle, we would have to travel 11.52 centimeters. This time they want to know the exact arc length. So we're going to use the formula arc length equals arc measure over 360 times 2 times pi times r, since they gave us the radius this time. So we have 160 over 360 times 2 times pi times 5. And when you put that into your Casio FX 300 ES Plus, what you should get out is 40 over 9 pi. And they're asking us for the exact answer. So if we had to travel from here to here along the edge of the circle, we would travel 40 over 9 pi feet.